We're going to talk about patterns and antipatterns, and when you hear that, you hear fun failure stories. Yes, this is what we're going to see. Before we start with fun failure stories, I wanted to start with a fundamental question of why we even bother to update software. And I believe that there are two main reasons. And the first is, obviously, we are all users, and what do we want? New features. When do we want new features? We want them now. Sebastian mentioned the changes that we experience. Think about how did you go about having a snake game in your phone, I would say like 15 years ago. What you had to do? You had to buy a new phone. Today, not so much. We're all used that all our world is getting better with time, and the way it's getting better with time is by getting new features through updates. We're so used to it that we now demand it, and if we have software which is not updated and not getting new features, we get annoyed, frustrated, probably will look at the competitors. Me personally, I switched a bank, which is a big hassle, over the functionality of their mobile app. I wanted more features. My bank didn't deliver. They lost a customer. So we want features. Another very important reason is security. And as every company becomes a software company, security vulnerabilities are the new oil spills, are the new big deal. And you can think about any security vulnerability, any personal information exposure, any catastrophe, Equifax, or any other. Those are now actually very, very big deals. And you can think about hassling with those vulnerabilities as when you learn how to drive, when you got your driver license, you saw this picture. And this picture have two different contributors to stopping distance. One is the thinking distance, and the other is braking distance. Those are completely two different aspects. Thinking distance has to do with light being registered in the eye, and then neurons fired in the brain, and then you actually realize that you need to brake, and you send signal to your foot that hits the brakes. This is the thinking. The other one has to do with physics and chemistry, the pavement of the road, and the quality of your tires, and the friction between the brakes. And this is like completely different aspect, but what they have in common that if we want to shorten the stopping distance, we need to fight with both. So we go about braking distance with having better roads and better tires and better materials for brakes. How do we battle thinking distance? We get away we get rid of people, because people are not very good in that. We replace them with autopilot. Autopilot is much better in shrinking this thinking distance. With security vulnerabilities, it's exactly the same. We have three different types of forces in play. All three of them should be battled differently. Identification is about how do we know that we were hacked. Sometimes it's easy, sometimes it's more difficult. We need to do that. Fixing, obviously, we write code, but mostly we update our dependencies which are exposed. And then the third is how fast we deploy. And those two are not the topic of today's talk, or maybe not even this conference, but the time that we deploy our fix and make our software less vulnerable, this is all about that. We need to update faster to be able to deploy fixes faster. And the thing is, this is not a concept that is unheard of. If we look at if you ask me, the most important document in our industry, and that's the State of DevOps report. Who heard about State of DevOps? Not enough, not enough. People Google it, read it. It was formerly from the organization called DevOps Research and Assessment Institute, led by Dr. Nicole Forsgren, and now they are all in Google Cloud, so they are the research department of Google Cloud, and they still keep doing this awesome report. This is where we are, and this is how we good, and this is how we should improve. And this is a very serious report. It surveys a lot of organizations, and in the end of the day, they separate those organizations by cohorts. You can see here we have the low performance in the bottom, the medium performance, the high performance, and the elite. And what is amazing is that 20% of our industry, every fifth organization, is actually in this elite cohort and do amazing things. One of the amazing things that the elite cohort does is the speed in which they can deploy. And you can see here the deployment frequency for the elite is multiple deployments per day, basically on demand when they want it. And this obviously allows us to deliver features faster and to make sure that the impact of security vulnerabilities is smaller. That's exactly why we're doing that. And this is not a new idea. Extreme programming, which year? 1998. Introduced the idea that short feedback is, I'm that old, introduced the idea that short feedback is good. Scrum, reducing cycle time to absolute minimum, that's 2000. Toyota Production System decided less than possible, deliver as fast as possible. Kanban, incremental change. All those agile practices that we live with for decades now all advocate more frequent and smaller deployments. So with that, my name is Baruch, as Sebastian introduced me, and I'm the Chief Sticker Officer at JFrog. That's a real title, that's a real business card. I'm also head of developer advocacy, and what I do is I speak with you. This is not a talk about JFrog. What you need to know about it is that we have an awesome booth over there with awesome t-shirts. Who got a t-shirt? Not enough. Who didn't come and get a t-shirt? We obviously also have stickers. We also do awesome software, by the way. And there is one more surprise in our booth, about it later. The most important part of this slide is obviously my Twitter handle. By now you realize that you all need to follow me because I'm very entertaining. And in case you forget, it's on the bottom of each and every slide. Disclaimer, this is an awesome cultural thing from an awesome book, Culture Map, by Erin Meyer. So you can see here, emotionally expensive, confrontational. The most nasty people in the world are from Israel and Russia. I'm from both. I apologize in advance if I didn't offend you. Yeah. Most important slide of this talk is this one. jfrog.com/show notes. You go there to get the slides, which are already there. The video will be there by tomorrow because I'm recording. At least I hope I'm recording. All the links are there, including Culture Map, and a place to comment, to rate, and everything else. By the way, also on the bottom of every page, if you forget, it's right there. Raffle, small raffle to thank you for being here as well. Okay, so let's talk about updates. I think the most prominent example in who wanted to accelerate, and everybody know it, is Java. You remember this? Who knows Java, about Java, anything? Heard the name? Everybody. Good. Okay. So Java is a programming language. They used to release very, very seldomly. The official release cycle was like 2 years, 1 year to 2 years. It usually took them like 4. And then back in 2017, 2 years ago, they decided no more. We're going to release faster because people want features and make sure that there are no security vulnerabilities. We need to release faster. Like Baruch said, he has no idea who I am, never mind. Every 6 months we are going to release. Whatever didn't make the cut goes to the new version, amazing. Year 2017, the Java version in production back then is Java, who remembers? 8. When this got out, now Java 8. And then they go like, since then they released every 6 months like a clock. Java 9, Java 10, Java 11, Java 12, Java 13. 5 new versions. We look at what people use. All the industry uses Java 8. And then you go like, what the actual fuck? Because the theory is solid. We want to release faster because people want faster updates. Why no one uses our software? And the answer is here. How do we update? And here's a small diagram for you how we make about taking software. Update available. Do we want it? If we don't want it, then we just won't update. Because there is no new features, nothing interesting, that's fine. It's like Java 9. No one wants it. Are there high risks? Sometimes there are no high risks. I can update the app of Netflix in my phone, and if it's broken, if it won't show my, my shows anymore, I'll go to YouTube, watch cartoons. That's still fine. No big deal. With Java? Hell yes. Huge risks. Do we trust the update? Do we trust the vendor? Who remembers, who trusts their vendors blindly now and update stuff? High risk. No one. Seriously, no one. That not used to be the case. Only a couple of years ago, if you had Mac and there was a new version of Mac OS, I would update like 5 minutes before my talk. Because why not? It's solid. Yes, high risk. I'm going to be without my laptop, but I'm absolutely positive that Apple won't break anything in my macOS update. Well, not anymore, right? Who is as stupid as I am and updated to the latest version? Yeah, not a lot of people, and it's been for a couple of months already. Exactly, that's my point. We don't trust the update. If we did, we just got update, but we don't. The next question is, can we verify the update? Sometimes it's not worth it. If it takes me a year to do acceptance testing for my Java in production, check all the servers and everything, and Java releases every half a year, I won't be in a rush to update, because what's the purpose? By the time I will update, they will be 2 versions ahead. I will just wait. And even if I will, it will take me a lot of time verifying, time-consuming verification, the acceptance updates. So what the problem is this. In the end of the day, even if updates are available, we are not taking them because we don't trust the vendor. And this talk is about how we work on this relationship. So let's get to it and see how a couple of examples of why we don't trust and what can we do better. Personal story. I bought a router from Google a couple of years ago. It was called then on Hub. Now it's called Google Wi-Fi. One of the best purchases of my life. Amazing. One of the reasons I purchased it, because of this. They promised a self-improving system. And that was a very interesting concept. I have my router. Over time, it will get new features. I love it. I like new features. So I bought it. And then 2 years ago, I was on a trip, February 2017, almost 3. I was on a trip, my wife is calling me, Baruch, the kids are sitting in the dark. And I'm like, do we have a power outage? And she's like, no, the internet is down. And they go like, Alexa, turn the lights on, Alexa, turn the lights on, and nothing happens. So that day, they learned that there is a physical switch on the wall that they can actually use. And also, I called my provider, asked them what's going on, and they're like, no, everything is fine. And then I get this email, and this email goes like, oops, sorry, we pushed an update to your router, and it reset it to factory settings. So now there is nothing we can do because we cannot reach your router because it's disconnected from the network. So please go ahead and reconfigure it. To get an email, you need the internet, by the way? Yeah, so I was on a trip, so I got it on the hotel Wi-Fi or whatever, so it was all fine. But there is a lesson to learn here. And the lesson is we need to implement local rollback for the devices which are outside of our control. So update went catastrophically wrong. Over-the-air patch cannot reach the device. What do? We want to have a previous version saved to rollback. We actually have this concept in our laptops, for example. When you change a resolution, you see this feature that if you don't click that everything is fine, it will roll back in 15 seconds. That's local rollback. It's exactly the same idea, but for the entire update for the entire system. And this is an IoT example, and most of you probably not in IoT, but I would claim that the T in IoT stands for things, and that means everything, including the servers that you are updating with your server-side software. So this is still a relevant example. Talking about IoTs, let's talk about fun stuff, updating cars. Jaguar I-Pace. Amazing car. They've been in the market for about like 8 months. Sold 80 cars in the entire United States. Huge success. Never mind. Couple of months after they released, they had a rollback, a recall, not a rollback, a recall, because they have a problem with software in their brakes. I mean, legit software in the brakes. The problem is obviously with recall, because recall for software update is ridiculous. Think about if you wanted to update your operating system on your Mac, you should have bring it to the App Store. This is how ridiculous a recall for software update for us software people looks like. For automotive people, that's the norm. You want to update your software, you go to a service. But that's just insane because too many reasons. Physical recalls are extremely costly. You need all the operation of the service, and also you can't enforce them. Problem with brakes, it's probably a big problem, but what you can do? You can send them a letter. You can send them a letter on a red paper. But in the end of the day, if they don't want to come, they won't come. Obviously, over there, updates fix it. Because you can push the fix that you want to push, and you don't need permission from anyone. So this is good. Now, the only thing which is better of the over-there updates are continuous over-there updates. Here's another example about cars. Tesla. Great, amazing car. People who do software finally made a car for us software engineers. It feels like driving a computer. Best thing ever. There are bugs. One of the most annoying bugs is phantom braking. Phantom braking, you drive on autopilot, sunny day, no clouds, no obstacle. Suddenly the Tesla slams on the brakes. When I'm alone, I'm like, okay, this is a software bug, I know how it works. When I'm with family, no one believes that it was an autopilot. They go like, why did you do that? And I'm like, no, that's not me. No, why did you do that? So yeah, it's a big problem. And I was really annoyed with that. And they promised a fix. The problem is that I didn't get the fix because I was waiting for chess to be completed. I kid you not. Those are the release notes. You see this small tiny thing here. Minor bug fixes. Minor bug fixes is the fix for the phantom brake. But you don't get this release because you need to wait for chess. Well, chess is important. You want to play chess once you're charging and everything. But really, people? Seriously? Now, there are some chess enthusiasts that don't use autopilot. For them, it's also very annoying. They want their chess. They want their chess now. Instead, they wait for phantom braking. They don't even use this feature, and they have to wait. The problem with software updates which are not continuous is that important features wait for not important features. And that's a very, very big problem. How do we solve it? We implement continuous updates. How many of you work on automotive self-driving cars and all? Couple of hands. Any IoT people? Couple of hands more? No one. So you will tell me, why are you wasting our time with that? Now, the thing is, our life is super easy, the server-side people, because we control the availability of the target, we control the state of the target, we control the version that we update for, and we control the access. The IoT people have none of that. So you can say, okay, they have tougher environment, but we manage to fail even in our own very, very simple domain. Here's an example. It's a little bit dated, but it's classic. 2012, a huge investment firm working with trading released a new version of software. New system reused old APIs, old flags. 1 of 8 servers wasn't updated. New clients sent requests to all the 8 machines. Some percentage of them got to the old code, and the old code did something catastrophically wrong, like selling instead of buying, or buying instead of selling, something like really, really bad. Now, what the engineers do, they're like, oh, there is a problem, let's unroll the update. So now, they take down the servers with the update, 100% of traffic hits the server that misbehaves. Good idea. No monitoring, no alerting, no debugging. Think about those people that now are in the crisis mode, in the war room. That's not what you need to see. And talking about, by the way, talking about software updates, of the operating system. Do not disturb mode didn't prevent that. That's really weird, but that's okay. Right, so people sitting in the war room trying to fix bugs, and every second they work on it, millions of dollars go down the drain. In the end of the day, $440 million losses in 40 minutes of trying to fix that, they went out of business. People suck at repetitive tasks. Don't let people do repetitive tasks. Automate everything. Do automated deployment. Frequent updates. Seldom deployments generate anxiety and stress, leading to errors. Instead, do it more. When you do it more, you develop a skill and a muscle for it. It's like a gym, and I know. State awareness. When you reuse old APIs, think about how things can go wrong in this regard. And when you roll back, keep it in mind as well. And last example, because they're going to drag me off the stage now physically, Cloudflare. New rules are deployed to battle bad guys. This is what they do all day long. Deployment of a single misconfigured rule took everything down. By the way, after this incident, I'm now 100% sure that the end of all of us won't be nuclear war or global warming or meteorite striking the earth. It will be wrongly configured regular expression. That's for sure. I can guarantee you. We have to give it to Cloudflare. They have sense of humor. Affected region on the status page, Earth. Jokes aside, what the heck, people? Canary releases allow you to prevent exactly that. You release to a small number of users, reducing the blast radius, and then you observe. If problem occurs, you stop the release, revert on update the affected users. All of you know what canary releases and progressive delivery is because your mom taught you when you were 8 years old. Doing your first laundry, you remember what they said? Yeah, that's this. Always spot test on hidden service first. Remember? This is true for laundry. This is true for software deployment. Those are canary releases and progressive deployment. Why we still didn't do that? I don't know. Anyway, observability. You have to observe what's going on because you need to know that something went wrong. Relying on user feedback only is not a good idea. You implement tracing, monitoring, logging, and then you know. And rollbacks. Fixes might take time. Users suffer in the meanwhile. Rollback what went wrong to prevent that from happening. If you cannot roll back, do feature flag. Allow to shut down the misbehaving feature from your API, using your API. And then, obviously, this fixes it as well. And the last example, MoviePass. It's a service that you subscribe and then go unlimited to movies. Shut down for several weeks to update their app. You will probably lose all your users if you do update for 4 weeks. By the way, they never came back up. They lost all their users. They lost all their business. They went out of business because they took their app, the only source of revenue, down for 5 weeks. Don't do that. Perform zero downtime over there, small and frequent continuous updates. So to summarize, continuous updates are frequent, automatic, tested, canary released, have state aware, observable, and you implement local feedbacks. That's a hard, but still, even if you don't do that, you're fine, do that. And in the end of the day, we work on trust. Do we want to trust the update? Yes, always. Problem solved. Our goal is to transition from bulk and rare software updates to extremely tiny and extremely frequent software updates. So tiny and so frequent that they provide an illusion of software flowing from development to update target. We call it the liquid software vision, and we wrote a book about it. And that's the other thing that you can get at our booth. So everyone can get this book. Just come to our booth and get it. And with that, corner cases. Who thinks that updating a plane mid-air, mid-flight is a good idea? No one. Oh, one hand. Thank you very much. One brave person. Okay. Did you know that Airbus 350 has a memory leak? and have to be rebooted every 149 hours, otherwise it freezes. Now let's say someone forgot to reboot it. And now it's mid-flight from San Francisco to Tokyo over a Pacific Ocean. Wouldn't it be nice to patch it and stop the memory leak, even in flight, because the alternative is just horrible? Who thinks now that that would be nice to have? Here you go, I convinced a couple of people. Let me tell you, this has already been done. Boeing 777 had software problem of stabilizing during turbulence. What they did is they put all the software engineers on board and take off. They debugged it mid-flight. They found the problem. They patched it mid-flight. They checked that it helped. And then they safely landed. And me personally, 777 is one of my favorite planes to fly on. Anyway, thank you very much. I'm at JBaruch on Twitter, Liquid Software, and come to our booth, show notes, and with that, thank you.